Hi everyone, I'm here with the absolutely fantastic Jim Bennett from Microsoft. Jim, do you want to introduce yourself?
Yeah, hi everyone. I'm Jim Bennett. I'm from Microsoft. I'm part of the academic cloud advocacy team over here, and yeah, I'm here today to have a bit of fun for the most cloudful time of the year, as we like to call it. So, can you just flip to my screen there, Chris?
Yeah, no problem.
Awesome. Cool. So yeah, as I said, we're here to celebrate the most cloudful time of the year. It's the holiday season. It's a time to have a bit of fun. So I thought I'd just throw together a whole lot of demos, show off a whole lot of technology, all with a nice holiday theme behind everything. So to fully introduce myself, I'm Jim Bennett. I'm part of the academic developer advocacy team at Microsoft. Now, you've probably never heard of a developer advocate. It's a fairly recent role, but essentially my job is to help students and educators be successful with Microsoft technologies. My particular areas of expertise are the Internet of Things, but anything cloud-wise I can help with. So if you're an educator and you want help running Microsoft software in your classroom, you want to deploy things to the cloud, you want to get some good teaching resources, get in touch. If you're a student, you want to learn more about our technologies, you want help, guidance, links to great content, again, get in touch. I'm here to create the blog posts, the videos, do sessions like this, create sample code, kind of anything I can do to make your life easier with Microsoft products. So anything, any questions, anything you want, just get in touch and I can help. And I'm all over the internet at Jim Bob Bennett. So Twitter, GitHub, Instagram, LinkedIn, Jim Bob Bennett. You can find me there. And yeah, so reach out, get in touch, and I'll help where I can. Now, if you remember only one thing from this session, remember this link, aka.ms/most cloudful time of the year. This will take you to a web page with everything I'm going to talk about today. It is not that one there, it is that one there. We've got links to sign up for Azure accounts, which is the Microsoft Cloud. We've got links to online documentation, GitHub repos with all the code I'm showing off, the hardware, all the tools I'm using. Basically, everything you need to recreate everything that I'm going to be showing today is in this one link. So you can follow this link and all your stuff's here and away you go. So let's start by wishing you a Merry Christmas. Now, during the holiday season, I call this the holiday season because, let's be honest, between November and January, I think there's like 22 different holidays across multiple cultures and religions. But during the holiday season, we like to wish people a happy Hanukkah, Merry Christmas, Happy New Year, Happy Holidays. We like to say these things to wish people a happy holiday. But we're technologists, we love computers. Excuse me. Yeah, we love technology, so why don't we let the computer do this for us? Instead of us doing it, let's let the computer do it. Now, we think about the rise of voice. It's kind of becoming ubiquitous in computing. I mean, just on my desk here, I've got an Alexa turned off over there so she doesn't wake up when I say her name. My phone has got a voice assistant. I have all these tools for doing voice. All around my house, I have voice control. I can ask my Alexa to turn my Christmas lights on, to open my garage door, to do all these things with voice. I can ask my Alexa questions, and Alexa replies, and does it all with voice. So how can we do this ourselves? How can we start bringing some voice into our code? So I'm going to zip over to a little bit of code here. I'm just going to run this first before I talk about it. I'll run this code, and sorry, Chris, can you make my code full screen?
Absolutely.
Legend. Thank you. So I'm running this code and it's like, hello, I'm Mia. What do you want me to say? So let's go. I could spell Happy Holidays.
Happy Holidays.
Okay, I hope that came through okay.
Yeah, I heard it.
You heard it.
Happy Holidays.
Yay. So what we're doing here is I'm typing in some text and it's speaking it. Now, this has been around for a number of years. You've probably seen these computers speaking for a long time, but they are getting a lot better now than they used to be. So originally, when you were doing things with text to speech, it would take the syllables in what you're writing and just convert that to almost mechanical sounding speech. The old fashioned sci-fi, take me to your leader, that kind of thing. These days, it's getting a lot better. You can understand context and the words. For example, if I like to read books. Oh, I could spell. Yesterday, I read a book.
I like to read books. Yesterday, I read a book.
So you notice that's more natural sounding than we're used to, the original text-to-speech of many, many years ago. First of all, the pause. I like to read books. Sentence over, full stop, pause. Yesterday, I read a book. So it's got the sentence structure there. But also, read and read are spelt the same. And so this understands from the context whether we're using read or whether we're using read. That is written the same. If I just were to type
Read.
that, it has to pick one because it doesn't know there's no context. But when it's got context, it can actually adjust what it says to match that context. And this is all done using the power of artificial intelligence. So there's super smart folks who've trained AI models to take text and then convert it to natural sounding speech. And it uses AI to work out what the correct pronunciation is, the pauses for sentence structure, read, read, all those kind of things. And the way a lot of this AI works is super smart folks will train this, and then they run this on really powerful computers. They usually run a lot of this on GPUs. The things that make your Xbox have fantastic graphics can run these AI models really, really fast. And they will run these up in the cloud. Now, you don't have to build these models yourself. You don't have to train an AI model. You don't have to get millions of audio and text files and bring them together. You can use these AI models that other people have created. Now, in the Microsoft world, we call these cognitive services. And these are pre-built AI services that you can use. We build these services, we run them up in the cloud, we maintain them, we bug fix them, we constantly improve them, and then you can call them from your code. And what's really cool is you can do this for free. We literally make a healthy tier of these services available to you for free for you to use. Now, I know there's tuned in today, we've got some folks from universities and also some folks from high schools. To use these cognitive services, you need what's called an Azure subscription. Now, if you're over 18 and you're a student in full-time education, you can sign up for an Azure for Student subscription. And for that, you validate with your university email address, get $100 worth of credit to last you a year, and then a free tier of a whole lot of services. If you're under 18, unfortunately, you will need either a teacher or a parent to sign up for a subscription for you because you need to be over the age of 18. We do have Azure subscriptions for 16-year-olds, but they don't include these AI services. So I remember when I was young, I was really excited to turn 18 because I could drink in a bar legally. But of course, nowadays, if I was 18, I'd be really excited I could finally get an Azure account. So that's a thing to look forward to. It's not about drinking beer, it's about the Azure account. So yeah, get yourself an Azure account and you can do all this stuff for free. So what I'm
thinking, Jim, that you have some school partners as well, because I know you work very closely with universities. Do you do some of this stuff with schools as on top of that as well?
We do some things with high schools. The problem with schools is the age of students. They need if they're signing up for accounts, we have to manage student data, which gets obviously managing kids' data can be a bit of an interesting issue. So we normally rely on schools to provide these kind of accounts. The school will manage it and then provide access for the students to do this. And then we try and do a number of activities with younger kids to get them involved. I'm going to be showing off something later, which anyone at any age can use, which is pretty cool. But what I will actually mention, let me just bring this link up. We run a thing called Imagine Cup. Come on. So we run a university student competition called Imagine Cup, where university students can put together their idea for a startup, something that's going to change the world, and they can win money, mentoring from Satya Nadella, things like that. We've now started doing Imagine Cup Junior, designed for students aged 13 to 18, where we teach them about AI. And the idea is you've got a whole lot of learning materials to learn about AI, and then you submit your ideas about how you can use AI to make the world a better place. So you've actually got, in fact, let me just, what I'm going to do, I send this to you, Chris, if you could just run that across the bottom of the screen. Yeah, the Imagine Cup Junior, we've got a whole of webinars coming up. The one for Introduction to AI and Machine Learning, we've already run that, but you can access the recording if you want to. But we've got other webinars coming up about AI in the real world, AI for Good, which is a Microsoft program for use AI for good, and then information on a hackathon, and then you can get together with your teacher, with fellow students, put together a project, essentially put together a presentation about what you want to do, use tools like Wik to build up a basic AI application, and then you can submit this and win prizes, which includes mentoring session from Microsoft Vice Presidents and the Magic Cup Junior Trophy. So if you're interested in learning more about artificial intelligence, the Magic Cup Junior is a great place to start. There's a load of great stuff on there. And this is designed for students to kind of go into in groups with parents or with educators. So a team has got a team of 1 to 6 students. And so as a teacher, if you wanted to teach AI, you've got a class of 30, you could put together 5 teams to maybe enter this. Or if you're a parent running a coding club, you can get together a group of students to enter this as well. So this is a great way for high school kids to get to know AI. Awesome, cool. So zipping back to our speech, the way this code works is that we have a Python library. I'm a big fan of Python. I know Chris isn't at the moment. He's having a bit of fun with his Python code, which we'll talk about in a minute. So this is using a Python API. So there's literally a Python package, a pip package. Got my requirements.txt, Azure Cognitive Services Speech. I install this pip package, and this brings me an API that I can use to do text-to-speech. And I set up a couple of variables for my Azure information. I have to go into Azure and say, I want the speech resource. I set up my speech configuration with my voice language. So it's ENGB, British English. I live in the US, but hey, I'm British English all the way. The voice I'm going to use to speak, this is a voice called Mia. I then create my speech synthesizer, and then I call speak text. So we've got 1, 2, 3, 4, 5 lines of code, and that makes all this work. 5 lines of code. Oh, and it's gone quiet.
5 lines of code.
There we go. 20 bit slow.
But it's worth saying, I mean, there's 5 lines of code here, but I'm assuming there's this many hundreds of lines of code up on the cloud.
Yeah, so behind the scenes, there's all the API that make it work. This makes a REST call over the internet to the cloud. The cloud runs these models, but the idea behind this is you don't care how they work. So behind the scenes, we could completely revamp our models, change how it runs. We could change it from running on GPUs to FPGAs, which are programmable processors, whatever. You don't care. You call these 5 lines of code and the magic happens, and we make everything else work for you. It's this idea of pre-built AI. We build it so you don't have to, and you literally just use these 5 lines of code. So we've got typing text, we get speech. This is great for, say, a visually impaired person. You want to wish them a happy holidays, you can get speaking to them. What about the other way? What about speech to text? Well, let's do the same thing. Happy holidays. I'm going to the shops. I'm going to buy 2 bananas and a pineapple too. So same kind of thing. We've got some smarts here. It's taking my voice and it's converting it to text, but it's not just listening for this sound is this syllable, this sound is this syllable. It's understanding my voice, my tone, my intonation, and it's understanding context. You think voices are very, very different. I have a different accent to Chris, for example. I live in the US. I'm surrounded by Americans with American accents. I used to live in New Zealand, New Zealand accent. We speak English, but we speak it in different ways with different accents. Even in one country, you get such different accents. I mean, one example would be when asking a question, we normally go up at the end of a question. It's like, hi, can I ask you a question? We go up. But the Welsh accent actually goes up at the end of the sentence, even if they're not asking a question. So it's the AI's got to kind of understand these different sounds, these different intonations, but it's also got to understand context. So like in this last sentence here, I said the word to 3 times. I'm going to the shops. I'm going to buy 2 bananas and a pineapple too. And it's understood the 3 different forms of to. Yeah, if you ever want to get your there, and there, right, you can try it out with one of these. The AI understands the context. Same kind of thing. Somebody's trying this AI up in the cloud. They run it on these GPUs, and we access it with 1, 2, 3, 4, 5 lines of code. Same kind of thing. I set it up. I tell it to recognize Great British English, create my recognizer. I wire up an event that gets triggered. So when it recognizes something, it triggers this event here, which prints it to the screen. I then start continuous recognition. And what will happen is this will listen on my microphone. When it picks up a pause, it'll send that up to the cloud, and it will process it. You can actually get the intermediate results. So as it picks up each word, it will process that, and you kind of have it building up the words on screen, or you can just wait and just get the whole recognized session at the end.
And that's fantastic, right? Because I mean, there's so many examples out there of when speech recognition's gone wrong. I mean, my favorite one is the live captioning from the BBC during the funeral of the Queen Mother, where it said, "And we will now have a moment's violence for the Queen." You know, there's loads of examples like that. I mean, the amount of times that silence and violence are two that in the kind of very classic BBC English that get mixed up quite a lot, and that's got that's picked up everything really quite well.
Well, what's also cool about this is, I mean, obviously, live captioning is fantastic. One great use case for this is live captioning. I've got a little Python app that will live caption what I say, so it'll just run across the bottom of the screen some text with the words I'm saying, which is pretty nice. But what's cool about this is we also have a custom speech model available. So this is a generic model. It's been trained on a huge amount of data from a lot of people, but that doesn't take into account specific scenarios such as certain accents, certain voices, or certain background noise. So we have a custom version of this that you can train up based on your particular needs. So you could literally train it up on BBC presenters and have a specialized BBC speech to text translator that you give it the audio files, you give it the expected output, and it will adjust the model to make it work better for the person from the BBC. So that's pretty cool. You can kind of do that. It also works things like background noise. If you've got factory background noise, you can train the model on that, so it kind of filters out that noise.
I mean, it's so comical, it's almost a meme at this point, right? I mean, I imagine most people by this point have seen the YouTube video of the comedy clip of the two Scots in the elevator. Voice activated elevator. Oh, it's brilliant. just if you're watching the video live, when this is over, just go onto YouTube and search for two Scots in a voice activated elevator. Brilliant.
Okay. Yeah, I have to check that out. Because you do get a problem with this. I mean, the classic problem we have in our household is the bias that is inherent in AI training, in that the Alexa devices are much better at picking up male voices than female voices. So I will ask Alexa to play some music, and she will play some music. And my wife will ask Alexa to play some music, and then my wife will shout and scream and get very angry because Alexa doesn't understand her. And this has been a noticed phenomenon that Alexa is not so good with female voices. But that's part of the bias in AI. When you train your data, you have to make sure you train it with a wide range of people. Mm-hmm. If you have a bunch of male engineers training these models, it will work for male voices. This is why diversity is important, because you can just catch these biases instantly by having a diverse range of people involved in your to build up your training data. Okay, so we've got speech to text, text to speech. We can handle, if you want to wish someone happy holidays and they're visually impaired, we can do it via text to speech. If they're hearing impaired, we can do it via speech to text. What if they don't speak English? What can we do about that? Well, let me just run another little demo I got here. Happy holidays. Happy Christmas. So what do we got here? I said happy holidays. In French is, and I'm going to butcher this pronunciation horribly, joyeux fête, and then joyeux Noël for happy Christmas. And I can't read Chinese, so I'm going to give up at this point. But we've got translation. So I have said something, and I've got a live translation. I speak and I get a live translation. There we go. So this has actually got a load of AI models trained on translation, and not word for word translation, because this word means this, because that's obviously not how translation works. It's taken, you think about a book, you can buy a book in English, you can buy the French version, the German version. It's been kind of rewritten to use idiomatic speech, to use the kind of phrases that people use. We use phrases in English all the time that wouldn't translate directly to a foreign language, because it only makes sense as kind of the metaphor that's understood by everybody. And so these AI models are kind of trained on that. And so they can take what you say and they can provide the appropriate translation for kind of a similar expression. And I've got, I say something in one language and I get a different language. Obviously, it's not perfect, because a live translation is a live translation. It's alive. It's not dead. It's alive. But I've got this translation going on. So I said in one language, I get it out in a foreign language. And I can get this as spoken word as well. So I can literally say in English, but it can be spoken back to me in French or Chinese. Great for practicing your language skills. Now, again, we're talking the 5 or 6 lines of code here to use the SDK. I set up my config, I give it my input language, which is Great British English, and my target languages, French, English, and simplified Chinese. I spin up a translation recognizer, wipe my recognized event, start my recognition, and then when I get my results, I've got the translations I can dump out. So, only a few lines of text, a few lines of code, we've got this translation working. Now, the immediate thing that I think of when I see this is universal translator. We can build a universal translator. How can we do it so I can speak in one language and I can speak to somebody who can't speak English and they can speak in their language? And guess what? 154 lines of Python and you've got a universal translator. Yes, I would demo this. Unfortunately, Chris very kindly offered to help with this, but he can't get any Python code running on his computer. He's got it set up wonderfully for streaming and for game development, and it's broken his Python development. So I can't demo this to you, but essentially the way this works is I say something in a language. So I launch my code, I tell it the language that I want to use, and I say something in that language. It then takes my speech, converts it to text. It sends that text over a thing called Azure Event Hubs, which is basically a big message bus. So I put it on one end, and then the person on the other end runs their code, and they pull it off the other end. And what they receive is a message that says, here is the text, and here's the language it's in. On their end, they know the language they want, and therefore they will then use a translation service, another AI service that runs with this translation. They will use that to convert from my language to their language, and then the speech service to say this out loud. They then reply in their language, gets translated to text, sent over to me with the text in their language. I then translate it and play it back. So it's a little bit like the old-fashioned CB where I say over, they say over. It's not 100% perfect, but it basically works. So my code, load up a few environment variables for my Azure connection details, listen for the language I want, so it checks the arguments for what language you want, and then sets up the speech recognition in my language, speech synthesizer, so speech recognition and synthesizer for my language, so the connection to the message bus to put message on, take it off. When it needs to send a message, it patches up the language, sends it over. When it gets one back, so we then start listening for speech. When speech is done, we send it over. If we get message back, we run through translation requests, hits an Azure SDK to translate it into the language I want, and then it speaks it out. A little bit of janky logic here, because if my computer's saying something whilst it's listening, you end up with a situation where it tries to then repeat it. So I say hello, somebody on the other end hears bonjour. Whilst their computer's playing bonjour, it detects their computer said bonjour, so sends hello back to me. My computer says hello, picks up this, so it kind of listens to itself. So I've got a little bit of logic to say, when I'm speaking, stop listening. You get the kind of CB radio idea, but a little bit of thing that says, if you've got a headset so the microphone can't hear the speakers, then that doesn't matter. And then that's it. When we receive a message, we translate it and voice it. And that's it. 154 lines of code, and we've got a universal translator that supports 80 odd different languages.
So I have a lot of interest in kind of careers from computing.
Mm-hmm.
And I'm seeing two very, very specific skill sets here. You've got the people who are building these models, these almost kind of generics code bases that are sitting on the cloud there for, as services ready for, computing as a service, waiting for people to access it. You've also got the job of the person who's writing code to kind of monopolize the functions and capacities of those services. Yeah.
I mean, there is pretty much multiple roles across the AI space. So some people are AI engineers. So there are people who will research the AI world. They will build up these models. They will train these models. They'll make these models available to anyone and everybody. The AI engineering is a job a lot of people do. There's actually a whole load more roles in the whole process, because somebody builds an AI model. How do you then deploy that model up to the cloud for people to use? So there's a whole idea of what's called ML ops, which is, if you come across DevOps, it's machine learning operations. So it's managing a model, an actual deployment of the model. So, because the people who build these models are usually researchers. They will build models. They understand the AI. They understand the maths. They may not necessarily be the best coders. So then you have people who can help take what they've built, expose that, And then once it's there, you need people to make sure the APIs are usable and supported. And then you have people at the other end who can actually use it. Yeah, you think about the Alexa on my desk. The team who built that Alexa, it's not the same person building the understanding of the voice and the same person building the speech model and the same person building the user experience they've got. It's very different roles. So some people are actually building the language understanding part. So they would not know anything about speech models at all, but they will understand language understanding models where you pick up intents and entities from a model. You know, you say to Alexa, I want to order a pizza. The intent is I want to buy the entities of pizza. So somebody's got to build those models to understand what the words mean once it's been put into text. So there's multiple different AI engineering type roles you can do. And then, you know, some people like me, I can't build an AI model. I got no clue how to build an AI model, but I can be an end user. I can build a universal translator, but I don't know how it works behind the scenes. And so you've got, you know, developers like me are using a lot of these AI technologies every day in the apps that we do. And we don't even need to be, you know, really funky AI. I built an app where you had to type in some codes from a page. So you sign up for an account to do something. It'll give you like a project ID, and you have to type it into the app. And I got bored typing it, so I put a little bit of code in there so I could literally hold the phone up, use the camera to photograph it, and then do OCR to put that into my app. That's me as an AI engineer. You know, I didn't build the AI. I just called some APIs to use it. So it's good to be aware of what AI can do, so you can be an end user, even if you don't want to be behind the scenes building these AI models. Cool. So that's speech. I will just zip back and say, you know, I said this stuff was free. This is how free it is. So you sign up for this for free. Speech to text, 5 hours per month. If you want to build a custom model, it's 5 hours per month. Text to speech, 5 million characters. For the really cool voices, 500,000 characters. Speech translations, 5 hours per month. So that's a lot for playing with, and that's completely free. And literally, if you go over that, we just stop you. You know, it's not like you do 5 hours and 1 minute and we hit you with a bill for $1,000. No, it's 5 hours per month and you cut off. It's not going to cost you anything. So that's cool. That's how we can wish you a Merry Christmas in multiple languages using speech to text, text to speech, and translation. Next up, it's beginning to look a lot like Christmas. Now, in the Northern Hemisphere, the holiday season is in the wintertime. You do get the same in the Southern Hemisphere. I used to live in New Zealand, middle of winter there. In July, you get Matariki, the Maori Winter Festival. And the reason we have winter festivals is it's cold, it's dark, it's miserable. So we want to eat lots of food, light the place up, and have a bit of fun. And so one of the things we do to make it look a lot like Christmas is lights. And I have some lights behind me. These are my lights. And they're kind of glowing a nice purple color. But you know what? I'm just gonna get my phone out here. And let's go red. Fine, let's go red. I just got an app on my phone here. Oh, look, it's got a nice shade of red. In fact, let's go green. So what I'm doing, I've got my app here. Chris, you just make me bigger. There we go. Got my app here. I've typed in 00FF00, which is the hex code for green using RGB. I tap my OK button there, and my lights go green. So I've got a nice app for controlling my lights. Now, yes, you can buy these from the shops if you want to, but that's boring. It's more fun to build it yourself, and that's what I did. These are Internet of Things powered lights. Yes. So how does it all work? The lights themselves are these. This is a W2812B individually addressable LED array, or a NeoPixel, as they're also known. And inside this little bit here is 3 LEDs, red, green, and blue. And by varying the intensity of the red, green, and blue LEDs, you can make all 16.7 million colors that you could possibly imagine, more than a human eye can see, and it's the same as what your TV can do. Now, you notice there's 3 wires here. Not sure make out that one's red, that's positive. This one's black, got black on it, which is the ground, and this is a control wire. So power goes in the red, down the black. LEDs, light emitting diodes. Electricity can only go one way, in one, down the other. And this is the control wire that's used to program the LEDs. Now, these LEDs are what's called individually addressable. And so from the code that calls this one here is LED 0, 1, 2. And what's really nice is the addressing is based on the distance from the connection to the device. So this is 0 right now. And on my one here, I've got 150, goes from 0 to 149. But if I were to tack this on the end, this becomes 150, 151, 152. So it doesn't matter how many you stick on there, you can just say, turn this light on, turn this light on, turn this light on, and it lights them all up. And these are relatively inexpensive for these kind of bits of hardware. This roll here, I think, cost me about $15. Oh, it looks like Chris is having a play. I gave him some secret stuff, which I'll talk about later. And he's having a play with that.
I was just trying to set it up ready to go, and I clicked it. Sorry.
That's all right. It's all good. It's all good. Now, how am I controlling this? I'm controlling this with a thing called a Raspberry Pi. If any of you came to my IoT on a shoestring lecture a few weeks ago, you'll know that I love these devices. Raspberry Pi, designed and built in the UK. It's a small board computer. The idea behind these was make something that's relatively cheap that kids can buy and learn to code. You pick one of these up, 30, 35 pounds, plug it into your TV, plug in a keyboard and a mouse, and you code in Python, you scratch, you learn to code, and away you go. Now, the plan, I believe, was to sell about 10 or 20,000 of these, and they've sold, I hate to think how many million Raspberry Pis in the time. They're up to the latest versions, the Pi 4. It's got 8 gigs of RAM in the top of the range one, quad-core processor, dual 4K HDMI out. They're an absolute beast, and they're still around $35. My current favorite, and if you still haven't written your letters to Santa, everybody, put one of these in there. This is a Raspberry Pi 400. It's a Raspberry Pi 4 that's been overclocked to, I think it's like 1.8 gigahertz processor, quad core, in a keyboard. So I plug in the mouse that comes in the kit. I plug this into my TV, into 2 TVs if I want to do. So 2 4K outputs there, and away I go, and I can code and I can do my thing. It's a fantastic bit of kit. Love the Raspberry Pis. So I've got a Raspberry Pi there connected to my lights. So I'm just going to zip over to my code to show you how all this works. So, Chris, can you flip to my code, please?
Yeah.
Thank you. So I'm actually running some code on my Pi right now. Now, if you've not actually seen this tool that I've been using, I was using it earlier, but if you've not come across this before, this is Visual Studio Code. It's from Microsoft, and it's probably the most popular developer tool on the planet at the moment. Okay. It's an open source developer's text editor. It's free, so it's fully open source, except for the brand bits and pieces. So yeah, if you build this from scratch, you don't get the Visual Studio Code icon because Microsoft owns copyright on that. But all the code of the application is all free, and out the box, it allows you to build and debug web applications, text files, things like that. And there's a whole lot of extensions you can bring in to increase what it can do. They can bring in more language capabilities, such as Python that I was showing off earlier, or Go, or C++, microcontroller development, kind of whatever you want, you can bring in different extensions. And one extension, which I love to bits, is Remote SSH. And this allows me to run VS Code on one machine, connect over SSH, secure shell, to another machine, and essentially code on that other machine. So I am connected to, where are we? 192.168.197.212, which is the IP address of a Raspberry Pi just there. You can't see it because it's a very dark case on a dark bit of wood in the darkness there. But that's a Raspberry Pi 4 that's connected there, and I am connected to it. My terminal, Pi at Raspberry Pi, I am running on my Pi. So I can debug my code, I can stick breakpoints, I can run this code, everything I would do if I was doing Python locally, but I can do that from here inside VS Code on my Mac. Yes, I work for Microsoft. I'm using a Mac because this is the new Microsoft. So in terms of controlling the lights, there's a NeoPixel library available from a company called Adafruit. Make this. You bring in NeoPixel and their Raspberry Pi WS281X controller that controls the different variants of the LEDs. I define my NeoPixel board D18, 150 pixels. So this is saying there's 150 pixels, which is what there is in there, and it's connected to board D18. Now on the Raspberry Pi, you have things called GPIO pins, general purpose input-output pins, and you plug things into this to control it. And pin number 18, it's on there, pin number 18, which is somewhere around there, that is connected to the control pin on the LEDs. Now you can power these from the Raspberry Pi if you want to, but when you get more than 4 or 5 LEDs, the power draw can actually burn your Pi out. So these are powered from the USB socket on the Pi. So positive and negative cables in the LEDs are connected to a junction box, connected to the LED socket, and then the control wire, and then the ground, just to make a control loop, is connected to GPIO pins on the Pi. So plug it in, a couple of wires to Pi, the rest goes into USB socket, and away we go. And then to change the LEDs, what I do is I say I fill up all the pixels with red, green, and blue values, and then call show, and it lights my pixels, and that lights it up. So that's the basics of lighting it up. But I'm doing this over the internet. You saw me do it from my phone. So how does that work? Well, that works by unlocking the power of the Internet of Things. So Internet of Things is all about taking devices and connecting them to the cloud to do stuff with it. Canonical example is the smart thermostat. Have a thermostat in your house. It sends telemetry data, as in your temperature, up to the cloud. The cloud does the analytics on it, decides that your heating needs to go on, sends a message back to your heating system to turn your heating on. Unless, of course, the cloud goes down, in which case you're stuck. There was a thing, I think, yesterday where Google had an outage and people couldn't turn their Nest controlled lights or their thermostats on and off because Google had an outage. So the downside to IoT is when things go wrong. But IoT basically allows your computers to talk to devices. So I'm running a thing called Azure IoT Central. So Azure IoT Central is an IoT software as a service platform. So it's a web app you can do to build an IoT application. And just so you know, Azure IoT Central is free for 2 devices. So this is a full professional industrial level software as a service platform that you can use to manage deployments of millions of devices for consumers, for industry, hospitals, smart cities, whatever. You can manage it from here, but you can do it for 2 devices for free forever. You can also do it for 5 devices for free for a week, and after the end of the week, your account just gets terminated, and you don't need to sign up for that. So if you want to do any IoT control, keep the number of devices down, won't cost you a penny. And the way IoT Central works is you define what's called device templates, and this is the contract between the device and the cloud. So in my case, my light controller, the contract is I can send a message to the cloud, to the device from the cloud saying off, to turn the light off, and I can send a message to say on, to turn the lights on. And if I look at the on message, I can pass in a parameter called color to tell it what color to turn the light on. And then I've also got a property called color, which means that when I set the color, it can persist that value. So if my device goes off, when it restarts, it can connect to the cloud, and the cloud can say, here's the color you want. Kind of like a smart thermostat. It can, when it knows what temperature it wants the house to be at, it can kind of download that from the cloud when it reconnects if the cloud gets an outage. So this is kind of my contract that I've got with my device. I then create my device, and I can have as many devices that I like sharing the same contract. So if I wanted to have multiple sets of lights, I could have multiple devices here. Let's say the first 2 are free. So this device uses that light controller contract. Click the connect button. This gives me connection details that I can use in my code to connect to it from my device. And then I've got access to these commands to kind of run these instructions from the cloud. So I can go here. I can go 0000FF. I click run. That sends a command to the device with this message here, which is 0 red, 0 green, full blue. And you see we go blue. Or I can do run the off one. That's Chris mucking about turning it red. Wait. Stop it. And we turn it off. So the way this kind of works in my code is it's like the Python code we saw before. Somebody's provided an API I can use. Azure IoT Device is the particular SDK that I use. What do? I run a bit of code to provision my device. So this is the security side of it, because I don't want anybody to connect to my IoT Central application. So I can run a bit of code to provision that device. So I have to use those special magic values that we saw in that connect dialog. That allows my device to connect. And then I can say to my device, listen to, where are we? Connects. And yeah, listen to whenever there's a command. That runs this bit of code here. So when we get a command, we say, what command have we got? If we got on, we then look at the payload, the 00FF I said before, and use that to light up the LEDs. If we get off, we set the LEDs to 0. And so this is all my code. I've got 156 lines of code for this one, and I've got a full IoT powered lighting control system. Now, I built an app for this. As you saw earlier, I control this from an app on my phone. So how did I build the app? Well, I built the app using a thing called Power Apps. So Power Apps is a product from Microsoft that allows low-code or no-code application development. It's designed for citizen developers, the phrase we like to use. So I don't know if anybody's ever done the kind of boring job that you think, yeah, you know what, I'm taking this spreadsheet, I'm copying these values, I'm emailing it over here. This whole thing could be automated if just somebody could automate this for me. You know, a lot of work experience folks end up doing this, or interns end up doing this. The idea behind Power Apps is you can then automate that yourself. You don't need to be a developer. And so I built a Power App to control my lights. I started off with what's called a flow, which is a way of connecting multiple components together. You know, connect to a spreadsheet, pull out some data, send it to email, things like that. And in my flow, I have a connector for Azure IoT Central. So can be a bit slow to load up sometimes. But the idea behind my flow is when I click a button, connect to Azure IoT Central, find the device, and then execute the command. And that flow will then send the command to IoT Central, which routes it down to my device. It's being very slow. Yeah. Power Apps can be very slow if you've got a lot of stuff happening, like live streaming, eating up your upload bandwidth. But then once you've got your flows, you then build your application. And you build it by just dragging and dropping onto a canvas. It's easy as that. You know, if I want to put a button on there, I can grab a button and I can drag it on and I can drop it. It's that kind of draggy droppy design. And then to things like how the button looks, I click on the button, I can change the color, I can change the border, I can change the text, I can do what I like with it. I've got a text input box here with the hint text of color, and it's called color input. And so I've kind of thrown together this UI. Doesn't look particularly flash, but for what I need, this is good enough. And then I can take my flows. It's taking forever to load up. But I can take my lights on, light off flow and assign it to a button. So I can say my on button, that's assigned to lights on. And when it runs lights on, it passes in color input.text. So passing the contents of this. So this was, I mean, this took about half an hour to build, and I'd never done this before in my life. So it's designed for so it's designed for low code, no code type scenarios. It's designed for people who are not developers, who can just come along and start building things together, start playing, start understanding. This one goes. So, so for a flow, now this is loaded up. It connects I choose my IoT Central application, my device template, my device, and it's the on command passing in some text. So that's kind of how I just literally drag and drop to build these flows. And I can have more steps, I can have branches, I can literally build logic through flowcharts and then assign that to the buttons.
And what are the restrictions on how you deploy those, Jim? I mean, so how many on the free subscription? How many devices can you have that app installed on?
So on the free subscription, you can do as much as you like as yourself. So you can't deploy these to production, but you can do as much as you like completely for free, because the idea is this is linked to a Microsoft 365 tenant. So essentially, this is linked to your Microsoft account. So as a company, we would have a Microsoft 365 account, and anybody who creates apps can share those apps amongst different groups inside the company. So if you're deploying to a company, you have to pay as part of your Microsoft 365 subscription. If you're playing at home, then you can do as much as you like, but it's just for you. So for learning, there is zero restrictions using what's called a community builder account. But obviously, if I want, I can't give this app to you because you need to authenticate as me.
Yeah, no, quite.
And it's got authentication all the way down. So for you to actually control my IoT Central application, you have to be a user on that application as well. So even if you were to get hold of my application to run it somehow, if you didn't have permission to control my lights, you wouldn't be able to control my lights. So it's got that kind of granular level of permission. Same as
which is quite reassuring in a way, right?
Yeah, you want that. I mean, if I was putting data from a database and you weren't allowed access to that database, we can't have you getting around security by grabbing the application and running it and accessing the database. So I kind of got those levels of controls. Yeah, I could put something in the middle to manage the data in a way that you can get access. So there's kind of all those levels of controls. So I can build this, and then if I run this app, put in the color, we're off at the moment, so let's go FF00FF. Love this color, and that'll go on. In a second, that'll go kind of a lovely pinkish color. So there we go. We've got an app to control our lights, to make it look a lot like Christmas. Now, if I wanted to make these available, you've probably seen Chris has been playing with my lights. What I have done is I've got what's called an Azure Functions app. So Azure Functions is serverless code. It's essentially a little block of code that gets run when an event happens. That event can be someone gets put in a database, something gets uploaded to the cloud, somebody hits a URL, and that code gets run. Azure Functions, guess how much Azure Functions is? It's free. So yeah, so for the first, I think 1 million calls a month, something like that, is free. So you pay it when you go over like the first 1 million a month. It's kind of a ridiculous amount for free. So all this stuff I'm doing is all free. So I'm running this locally. It's giving me these local APIs. And then behind the scenes, my Azure Functions code hits a URL. This URL actually talks to IoT Central. So you can make a web request directly to IoT Central with authentication tokens to control the lights. I've got this running locally. And so if I run this, that can turn my lights on, turn my lights off. And then I've deployed this to the cloud. So from inside VS Code, I've written this, run it locally, I can debug it locally. Then when I'm ready, I can deploy this to the cloud. That runs up in the cloud. And so if I go back to these URLs, AKWS, turn dimmed lights red, green, and off, run those, and that will control my lights. And obviously, anybody can do this. This is open to the world. So if anybody wants to muck about with my lights for the rest of the session, these are the links. Just do it. Just play. Just try not to get it flashing too much, so end up having a seizure or something.
Unfortunate event, yeah.
Yeah, that would not be good. Cool. Okay. Now, you're a mean one, Mr. Grinch. Some people love the holidays. Some people don't love the holidays. So wouldn't it be good if we could find a way to kind of easily distinguish between people who like the holidays and people who don't like the holidays?
Mr. Grinch did like the holidays eventually.
His
did.
Heart
just needed to grow a few sizes.
His heart needed to grow 3 sizes that day, yes. But imagine before his heart grew 3 sizes. So imagine I had a website here, and I look at the camera. And I click this button, and oh, I'm Jim. I'm 69% Jim, 31% Grinch. I'm not very Grinchy. Okay. But then imagine, for example, if my heart was 3 sizes too small, and I was a mean one, Mr. Grinch. Oh, yes. I am 96% Grinchy. So we have
I just love the fact that it detected you as 31% Grinch without the mask on.
Yeah, okay.
That's really unfortunate.
Hey, don't mock me or I'll come down your chimney and steal all your presents in your tree. So how does all this work? How have I got a website that can tell whether it's me or the Grinch? And I'm doing this with a fantastic tool called Loeb. So Loeb, you can get this from, what's the website? Loeb.ai, and it's free. Free tool from Microsoft for free. Kind of noticing kind of this free thing going on here. Yeah, it's a holiday season. This is my gift to you, all the free stuff. So Loeb is what's called an image classifier. So what you do is you capture images. You can either import them or capture them from your camera. And then you label those images. And then it learns how to recognize those images and then gives you a model you can then run to classify your own images. So this is based off a thing called transfer learning. So the way that these super smart AI people build image classification models is they take thousands, tens of thousands, hundreds of thousands of images of cats and dogs, put that through these really complicated neural networks, and it comes out recognizing cats and dogs. But obviously, I don't have 100,000 images of me in a Grinch mask. I don't have 100,000 images of me without a Grinch mask. So how can I train a model with less? And that's where transfer learning comes in. Because it turns out if you train a neural network on a whole lot of different things, so it's got 1,000 different types of inputs, billions of pictures, and 1,000 different kind of results of what it can be, bicycles, cars, hippos, what have you, you can actually take off the edges of the neural network and then retrain your network how you want. Because without the edges, without knowing that this input came out as a hippo, this input came out as a giraffe, what you've got essentially is a thing that can recognize a curve, a straight line, a block of color, a shape. If anybody's got young kids or remembers back being a young kid, the shape books where, this is a triangle, this is a square, this is a semicircle, and then it's got a semicircle with a rectangle, a triangle, this is a sailboat. You can kind of think of it like that. You teach it it knows how to recognize all the shapes, but you say, This combination of shapes is a sailboat, this combination of shapes is a car, and then it can recognize sailboats and cars from then on. And so this tool, this doesn't run in the cloud, this runs completely locally. So nothing happening in the cloud, no usage of your network, nothing like that. But it allows you to bring in images and train them. So I can go here, I can bring in images from my camera. I just need to choose the right camera because I have lots of cameras, virtual devices.
Tell me about it. I've got this whole array. This is basically a miniature TV studio here now.
It's kind of what you need for this kind of stuff. And yeah, there we go. So what I can do, I can come here and I can choose my labels. This is Jim. And then look at the camera. I can click and it'll take a photo. Or I can hold the button down. Kind of move around a bit to take pictures. And that will take pictures and then start training the model behind the scenes. So in a second, the train will start going and it'll start training this model. So behind the scenes, it builds up a model, which is pretty cool. Yeah, that's all I had to do to get the model going. I can do the same. I've got 47 images, 22 Grinch, 25 me. Yeah, it did pop up a little thing to say you might want to put a few more images for Grinch in there. But you know, you need like 25 images, that kind of thing. And then once you've got it going, downside to Loeb is it's very CPU intensive, and I'm running on an old Mac. My brand new Mac is delivery estimate is from yesterday till next Monday, but they haven't even shipped it yet. So I'm running on old hardware. So if it will go to the play thing, I can actually play with this. I can run the camera, and I can actually have it identify me or the Grinch. It's running a bit too slow, so we'll forget about that for now. But what I will bring up is the export dialog that pops up. So once I've got my model, it's like, yay, inside Loeb, I can play with it. I can have a look at me. I can have a look at the Grinch. But I can also export the model. And so that will package up the model that I've got and give me files I can use. So I can do it as Core ML, which runs on Apple platform, so iPhones and Macs. TensorFlow Lite, which is designed for Android. TensorFlow JS for web applications, normal TensorFlow for Python, Onyx, which is a cross-platform AI standard from Microsoft and Facebook, or a local API. So it just runs locally and gives me a REST API that I can hit to access my code. So I can take the model and I can export it, and I can do what I like with it. This is free. You can do what you like with it. And so what I've done, I'm going to quit Loeb because it really does kill my CPU. What I've done is I've exported that model into a Flask app, so a Python app. So I got my model, my save model, and my variables. So I've got all the kind of the parts of my model that I need. I've got a bit of Python code. This was exported as well with the model, which has got the code that needs to do it. I don't know what any of this does. I don't have to care what any of this does. Somebody else wrote this code for me. And then I have my application. So this is a Flask application. So Flask is a web framework for Python, allows me to run web applications. I've got a HTML template, which has got a video attribute in there. So it will capture from my camera and display it on screen. It uses the various media devices APIs. I don't know JavaScript. I literally copied and pasted this off the internet to make it work. But this will access my camera, display it on a video thing, give me a button. When I click the button, it will capture the image, send it to my application, and it will run that through my model. So I set my image as a pillow image stream, which is just a standard Python image format, runs it through my model, gets back the top prediction and then the values for the different labels. So everything works with this image classification with percentages. You saw, Chris was joking, I'm 31% Grinch. This is never yes or no binary type answers. It's always, this is the percentage that you're this label, this is the percentage you're this label. So if you're ever using this kind of stuff, you can't just necessarily pick the one with the highest percentage, because it could be 51% this, 49% that, and it could actually be that, yes, that is actually a muffin, not a chihuahua. So you have to, you've got to make sure you've got a good confidence score before you can make any predictions with this. But yeah, this gives you what it thinks is the most likely one, and then it gives the actual values, which I then show on screen. So, exported model, 35 lines of code, of Python code, and 60 odd lines of HTML, a little bit of CSS, and that gives me an application. So it's running in VS Code. I can actually launch it from here. I can just go into my code folder. I can run it all locally, Python, -m. I can run it locally. That will spin it up. That's got my code running locally, and I can do my thing. Now, obviously, yeah. Oh, at least it would do if I'd actually bothered to import my packages. But as well as running it here, I can deploy this to the cloud. So what I've done from inside VS Code, I've deployed to Azure App Service, and that sits there. This is running the cloud. If you actually go to grinch-detector.azurewebsites.net, you will do this. You will try it out. You may not get good results because it's trained on me, right? So if you're a slightly overweight, middle-aged white guy with no hair, it may recognize you successfully. Otherwise, it may not, because this is bias in AI. This is bias in AI. If you're naturally green-skinned, wearing Santa hats, it may flag you as the Grinch when you're not the Grinch. So, a bit of bias there. But you can kind of see this in action and play this if you want to. Jim,
out of interest, then, what happens if you wear the Santa hat? I'm just curious as to how well the AI copes with that.
It's sewn on, but let's I can just balance it on my head with the green thing hanging down the back.
No, it just looks like you've got a green ponytail. That's fantastic.
There you go. 93% Jim.
Wow, okay, brilliant.
Yeah.
That's a lot better than I was expecting, actually. I mean, when I played with similar kind of trained models, I would have expected that to have confused it a little bit.
Yeah. No, that seems pretty good. But things again, that's the kind of thing I should be training the model for. So, I want to be, if somebody says, oh, what about this situation? Right, I should probably add that to the model and retrain the model. Cool. Okay, we're getting close to time. So it is the most wonderful time of the year. And what makes it wonderful is everybody coming together at holiday season. So wouldn't it be nice if I could bring together everything that I've shown you so far today and control my lights in multiple fun and interesting ways? So what we could do, just as a bit of fun, I can zip over here and I'm going to run this. Lights red.
Turning lights to red.
Lights green.
Turning lights to green.
So there we go. I've got speech to text. So listen to the words I say. Nothing flash here. It's just a simple, if the text is lights red, lights green, lights off, do something, it'll speak back to me and turn the lights. So I've got full voice controlled, light controlled. I can have this application running all the time in the background. And instead of using my Alexa to turn my lights on, I can say lights on, lights red, lights green, and use that to control my lights, all by calling the same little Azure Functions URLs when I get the results of speech. But that's cool. But also, should I have Christmas lights if I'm the Grinch? If my heart is still 3 sizes too small, should I have Christmas lights? Well, you know what? How about I run a variant of my Grinch detector, which is running locally. Wait for this to actually start up. Come on. Give us a few seconds. Just loading the TensorFlow model in the background, getting everything ready. There we go. Come on. While that's loading up, I'll just get the website ready. Go over here. 1, 2, 7. Come on, are you running?
So I've seen some very similar kind of examples of this where people are designing kind of home IoT-based security systems, where if people are coming up to the door and it's not recognizing them as an allowed person, it's doing things like changing the lights and internal lights to red and things like that.
Yeah, so you can do that. You can train the models yourself. There's a particular thing you want. Or we do have a face service, which is part of our cognitive services, where you can train it on certain people's faces. So I can train it on my face and your face. But then if the camera picks up an image that's not me and not you, it could then turn the lights to a different color. Or we could do it based on certain images. So you could train it on, if it's the Amazon van outside, then we know it's actually a delivery, so it doesn't matter who the person is. So light up differently to say that I'm about to get another package. So anyway, let's just quickly control my lights. I've lost my sound out. There we go. There we go. Because I'm the Grinch, my lights go off. And that was 100% Grinch. So sorry, we need to turn the lights off, hide from the Grinch. But now, of course, we're 100% Jim, 0% Grinch, and my lights go green. And that's how we can bring them all together for the most wonderful time of the year. So that is, with the best pun possible, that is a wrap. Sorry. I had to. Thank you so much. I'm Jimbo Bennett across the entire internet. Come find me anywhere. Get in touch. Connect. Ask me any questions. I'm here to help you be successful. So if you're an educator, you want to bring some of these technologies into the classroom, I can help. If you're a student, you want to know more, got questions on internships at Microsoft or just how to use our tools, just get in touch. And then aka.ms/ most cloudful time of the year. That's the link to everything.
Brilliant. Thank you ever so much, Jim. That was absolutely fantastic session. Thank you for coming back again.
No worries. Love it.
Just to add to what you were saying before, really recommend people following Jim on Twitter and LinkedIn. You post loads of really useful hints and tips and useful bits of tech advice. So absolutely really recommend Jim's social content.
Thank you very much. Yeah, no, it's a lot of fun. So thank you. And happy holidays from me and everyone at Microsoft.
Brilliant. Cheers, Jim.
Thanks.